Hi guys, so today in this video we are going to be going over dilutions. For these you're definitely going to need a calculator in order to solve these problems. Alright, well, let's jump in. So a dilution, anytime you're diluting something basically means you're making it, I always think of like something that's really dilute, it's weaker. So what's going on is we are adding more solvent without adding any more solute. So then you thoroughly mix it to make sure it's all identical. But the fact that the solute makes the same allows us to be able to actually calculate what our new molarity is in a much easier way than having to go back and solve for moles divided by liters again. So our moles before dilution should be equal to our moles after dilution. So from molarity, we know that the moles of solute equals the molarity times the volume. So we can substitute MV, molarity times volume, into the equation, and we get our dilution equation, which is M1V1 equals M2V2. And that is our dilution equation. The subscript 1 basically tells us the before dilution, and then the subscript 2 is after dilution. So M1 and V1 should be your before dilution molarity and volume. M2, V2 should be your after dilution molarity and volume. It doesn't have an official name, so we just call it the dilution equation. So we're going to jump in, solve a couple of these problems. This will probably be some of the shortest notes we've ever taken because it's pretty easy. So you have 53.4 milliliters of a 1.5 molar solution of NaCl, but you need some 0.8 molar solution. How many liters or milliliters of 0.8 molar can you make? All right, so let's see what we've got. So we've got 53.4 milliliters. That's a volume, and that's our before dilution volume. So that's going to be V1, and we have 1.5, which is going to be our M1. We want to make 0.8 molar solution, so that'll be M2. And we want to know how many milliliters, so V2. So V2 is what we are looking for. So our equation is M1 V1 equals M2 V2. We're trying to solve for V2, get it by itself. I like to manipulate my equation before I plug in the variables because I just think it's a little easier. So to get V2 by itself, I would need to divide both sides by M2. When I do that, I get that V2 is equal to M1 times V1 over M2. All right, we're just going to go ahead and plug in our values. So M1 is 1.50 molar times V1, which is 53.4 milliliters, all over M2, which is 0.8 molar. All right, and then we're just plugging it into our calculator. I do want to show you guys that our units do cancel out here. So I have molarity on top, molarity on bottom, leaving me with milliliters as my final unit. And so I can plug it into my calculator, 1.5 times 53.4 divided by 0.8. And I get 100.125 when I do that. Now, we have to take into consideration sig figs. So remember, anytime we're multiplying and dividing, we always are going to use the fewest number of sig figs. So in that case, I have 1.5 has 3 sig figs, 53.4 has 3 sig figs, and 0.800 also has 3 sig figs. So all of them have 3 sig figs, so my answer is going to have 3 sig figs. So my answer will be 100 milliliters. Now, this is important. So in molarity, whenever we're solving for molarity, our volume has to be in liters. And so if we're not in liters, we have to convert to liters. But you'll notice that in our dilution, we don't have to convert to liters. Any volume measurement is absolutely fine, just as long as the same one is used on both sides. So if it's asking for liters and it gives you milliliters, then you would have to convert. But other than that, as long as it's asking for milliliters and you have milliliters, you're good to go. Only when they don't match do you need to convert. So nice and easy. All right, let's do another example. So, example 2, 100 milliliters of 2.500 molar KBr solution is on hand. You need 0.5500 molar. What is the final volume of solution which results? Okay, let's go ahead and label our variables again. So this 2.5 right there is going to be our M1, and our 100 milliliters is going to be our V1, and this 0.5500 is going to be our M2. We are looking for V2 once again. All right, so our equation is M1 V1 equals M2 V2. We're solving for V2, so we're going to divide both sides by M2. We get that V2 is equal to M1 V1 over M2. We'll go ahead and plug in all of our values. So V2 is equal to, and my first molarity is 2.500 molar times my first volume, which is 100 milliliters, all divided by M2, which is 0.55. All right, and then we'll just plug it on into our calculator. So 2.500 times 100 divided by 0.55. And I got 454.5454, so on and so forth. So let's talk about our sig figs again. All right, once again, when we multiply and divide, we go with our fewest number of sig figs. So in 2.5, I have 1, 2, 3, 4. 4 sig figs there. 100 has 1, 2, 3, 4. And my 0.5 has 1, 2, 3, 4. So my fewest number of sig figs is going to be 4. All of them have 4. And so my volume should have 4 sig figs as well, which would give me 454.5 milliliters as my V2. Okay. Sometimes the problem is going to ask you how much more water must be added, not just what our new volume is, but how much more water is going to be added. In that case, we would basically subtract our total minus how much we had to give us our volume. So in this case, this one, 454.5 minus the 100 that we started with, we would need to add 345.5 milliliters. That's not always, go ahead and answer that question. If I ask you, answer the question the way it is. But just know that it's bad to measure out the proper amount of water because volumes are not additive. So I could potentially add 100 milliliters to 354.5 milliliters and actually not end up with the volume being 454.5. So volumes are not additive actually, and so it's we can't really measure them that well. So basically all we do is we just add enough water to get to that volume without actually caring how much water we're adding. So do answer those questions, but just know that volumes are not additive. All right, I am going to solve one more with you guys and then leave you guys with the last, maybe I'll solve 2 more with you guys and then leave you with 2 to solve on your own. All right. So this one says a stock solution of 1.00 molar NaCl is available. How many milliliters are needed to make 100 milliliters of 0.75 molar solution? Okay, so we have this start as our starting solution. So this is going to be our M1. We do not know our V1. So V1 is what we're looking for. We want to make 100 milliliters. It's going to be our V2. Of 0.750 molar solution. So it's going to be our M2. So we are looking for V1. So V1 is going to be equal to M2, V2 over M1. And we're just going to plug in all our values. So V1 is equal to 0.750 molar solution times 100 milliliters divided by 1.0 molar. All right, so then we'll plug it on into our calculator. So 0.75 times 100 divided by 1. And that gives me that I should have 75 milliliters. So once again, I'm going to check sig figs of 1, 2, 3 there. 1, 2, 3, 4, and 1, 2, 3. So our fewest number of sig figs would be 3. So our volume then has to have 3 sig figs. So it would be 75.0 milliliters for our V1 because of those 3 sig figs. All right, I'm going to solve one more with you and then leave you guys to do the last two on your own. So it says, what volume of 0.25 molar KCl is needed to make 100 milliliters of 0.1 molar solution? So once again, looking for V1, have my M1. This is going to be V2, and this will be M2. So V1 is equal to M2 V2 divided by M1, and I'm just going to plug in my values. So 0.1 molar times 100 milliliters, all divided by 0.25 molar solution. And then plug it on into your calculator. And I got 40 milliliters, but again, my fewest number of sig figs is 3 here. So it would be 40.0 milliliters. That's my answer. All right, there are 2 more questions on this notes worksheet. So I want you guys to go ahead and pause the video now to solve those, and then we'll go over them. So pause your video. All right, let's go over them. So for this first one, we were given M1, M2, and V2. We were looking for V1, so I plugged it on into my equation, and I got 0.11 liters as my answer. All of these have 3 sig figs, so my answer needed to have 3 sig figs as well. And for my second one, almost identical problem, and I got 0.167 as my final volume there. All right, that's dilutions, guys. Hope that this video was helpful. Feel free to email me if you have questions. Have a good day. Bye.